Athletes, today we're going to look at number circles. We're going to explore patterns with odd and even numbers. So we're going to explore how odd and even numbers behave when we look at differences in sums between connected numbers in a circle. Here are some key questions. What happens when we place different types of numbers next to each other? Can we find a pattern based on odd and even rules? And how can we use what we observe to make and test predictions? So are you ready to think deeply, test ideas, and look for number patterns that always or never work? Well, we're going to start with 3 number circles. So if you have the worksheet, you can follow along with the worksheet and you can choose different numbers than I'm choosing. So in this one, we're going to choose 4 of the numbers from the list 1 through 9. We're going to put them in the squares below so that the difference between the joined squares is odd. And only one number is allowed in each square. In other words, I couldn't put the number 1 here and the number 1 here. So here's an example. I'm going to use 4 different numbers. I'm going to use 2, 5, 4, and 9. So the difference is going to be odd because 5 minus 2 is 3, 5 minus 4 is 1, and 9 minus 4 is 5. For the next one, I use 3, 6, 1, and 8, and 8, 7, 2, and 5. So what do you notice about the numbers in the circle when the difference is odd? You might want to pause the video here. Okay, here's what I noticed. I noticed that I needed to have an odd number next to an even. So when odd, even, odd, even, even, odd, even, odd, even, odd, even, odd. I also noticed that I couldn't have 2 even numbers or 2 odd numbers in the square that were next to each other. So I couldn't do like even, even, or odd, odd. So let's determine the sum of each pair of the joined squares. So we're going to add them. So you can see that the sum is 11, 7, 9, and 13 for the first circle. The second circle is 11, 9, 7, 9. And for the last circle, 13, 15, 9, and 7. So what relationship exists with the sum of each pair of joined squares? Again, you might want to pause the video. I notice that the sum is always an odd number. So let's verify or prove that this relationship is true by completing a circle with 4 numbers from numbers 10 to 19. So again, I'm going to do even, odd, or odd, even, odd, even. In this case, I did odd, even, And now we're going to find the sums, 29, 25, 29, 33. So this verifies that the numbers need to be odd, and then even. And the sum is always going to be an odd number. Now let's go on to the next part. And the next part is 3 new number circles. So again, just like before, we're going to choose 4 of the numbers from the list 1 through 9. But this time, we're going to put them in the squares so that the difference between the joined squares is even. Just like before, it's only one number allowed in each square, and you have to use 4 different numbers. So here we go. I used 5, 3, 1, and 7. Again, if you subtract these, the differences are all even. 8, 6, 4, and 2, 9, 3, 5, and 1. And what do you notice about the numbers in the circle when the difference is even? Again, pause the video. And I noticed that all the numbers in the joined squares had to either be odd or all of them had to be even. These are all odd, even, odd. Then the difference would always be even. So just like we did before, let's determine the sum of each pair of the joined squares. So in the first circle, we have 12, 8, 4, and 8. The second circle, 6, 14, 10, and 6. And the last one is 10, 12, 8, and 6. So what is the relationship with the sum of the pairs when the difference is even? Again, you might want to pause. And I notice that the sum is always an even number. So let's verify this relationship by completing 2 circles with 4 numbers. Again, we said that they all have to be odd or they all have to be even. So I started with the even ones. So 10, 14, 16, 18. So I'm going to put just odds in this one. 11, 15, 13, and 17. Let's find the sums. We get 28, 24, 34, and 30. 28, 26, 28, and 30. So the circle on the left verifies that all the numbers need to be even for the sum to always be an even number. And the circle on the right verifies that all the numbers need to be odd for the sum to always be an even number. Therefore, the numbers need to either be all odd or all even for the sum to be even. So what did we learn about odd and even number circles? Well, when the difference between connected numbers is odd, the numbers must be one odd and one even. And when the difference is even, the numbers must be both odd or both even. We discovered that these patterns also affect the sum. Odd plus even equals odd. Even plus even equals even. Odd plus odd equals even. These rules help us predict, verify, and understand how numbers relate to each other. And that's what math is all about. If you like this video, click the like, leave a comment, and if you haven't subscribed, I'd love it if you did that. As always, thanks for watching.